Hello, everyone, and welcome to the review for Unit 1 of Geometry called Introduction to Geometry. In this unit, you were introduced to some of the terms and theorems that you'll be using later in the course, and I'm going to just go over some of the things that you would expect to see on the quiz or on the unit test. First of all, you talked about several terms, and these might have seemed confusing at first because you're already familiar with these, but they have a specific definition that we're going to stick to while we're working in geometry. First, there were three undefined terms. The reason they're undefined is because they have kind of a vague meaning. We kind of know what they mean, but there's no way to put into words exactly what they mean. The first is a point. It just designates a place in space. It doesn't have any dimensions, so it doesn't really exist, right? But we kind of know what it is. And it can exist on a line, it can exist on a plane, but it is defined as no dimension, no physical characteristics, just a place in space. A line, on the other hand, has one dimension, it has infinite length, and you write a line by naming 2 points on that line with a two-arrowed line above it. A plane has two dimensions. It goes infinitely in any length and any width, but it doesn't have any depth. To get depth, we'd have to go to space. Now, we also introduced you to some defined vocabulary, and that is several of the things that we talked about, including array. Array is like a half of a line because it stops at one end, but it goes infinitely in the other direction. But the thing you have to be careful about with array is they're named with the point first, the end point, and then some other point on the ray that goes in the direction that the ray goes. So ray AB is not equal to ray BA because ray AB starts at A, goes in the direction of B, whereas ray BA starts at B and goes in the direction of A. A line segment, on the other hand, has two endpoints, and those are the 2 points on the segment that have to be used to name it. And it has a straight line above it that doesn't have any arrows. Opposite rays are a special kind of ray we're going to use a lot in this course. And in order to be considered opposite rays, all three of the points have to be on the same line, and they have to connect at the end point of each ray. So in this case, as you can see, the ray AB and ray AC are opposite. They both start at A, B goes to the left, A goes to the right, but they are part of the same line. These two opposite rays make a single line. Okay, midpoint and betweenness. These are two important theorems that you talked about, and this is the way they're defined on your test. If the measure of line segment RS is equal to the measure of line segment ST, then, and they are collinear, so they would have to be lined up side by side, then S is exactly between R and T, and it's called the midpoint of RT. Remember, midpoint doesn't mean just someplace in between, it means exactly in the middle. Conversely, the betweenness theorem says that a line segment AB and a line segment BC on the same line, just like what we talked about with midpoint. In this case, if you can add these two segments together to make line segment AC, then point B has to be between A and C. It doesn't have to be exactly in the middle, just somewhere between them. And remember, we can add up lengths of line segments because they are finite. We talked about the terms collinear and coplanar. 3 points may be collinear, but they don't have to be. 2 points will always be collinear. 3 points, if they are not collinear, create a plane. So you can see points A, B, and X here on plane P are all existing on the plane, and they define this plane. The plane passes through each of the 3 points. any 3 points are always coplanar, even if the plane is not the one in the illustration. 2 lines intersect at exactly 1 point, no matter where, well, if they intersect. If they intersect, they intersect at exactly 1 point, whereas 2 planes, if they intersect at a whole line. We talked about postulates and theorems, and this is basically what the rest of the course is going to be focused on. Postulates are statements that are accepted without any proof. So we talked about some of our definitions and things like that, betweenness, things like that. Those are postulates. Whereas a theorem has to be proven using those postulates, other theorems, and the definitions that we learned. And we're going to be working a lot on that in the next unit. We learned a few properties that might be reviewed to you, and I know a lot of them were listed in your lessons, but the only 2 that show up on the test are the inverse property of addition. Remember, inverse just means to undo what's done. So the inverse property means if you have any number, here represented by A, and you add the opposite of that number or the inverse of that number, together they will add up to be 0. The 2 numbers that add up to be 0 are opposite each other, and that represents the inverse property of addition. The multiplication theory of equality means that you have to multiply both sides of an equation by the exact same thing to keep it equal. In this example, b is being divided by -2, so you will choose to multiply both sides of this equation by -2 in order to solve for b. If I multiply b over -2 by -2, the -2's cancel out, leaving just b. But I have to remember to multiply the 18 by -2 as well, which will result in -36. So in this case, b equals -36. When you have an equation, 2 things are equal to each other. If you want to change them, you have to change them in the same way on both sides to keep it equal. That's why it's called a theory of equality. In addition to the multiplication theory of equality, there's also an addition, subtraction, and division properties of equality. But the one on your test will be the multiplication one. Okay, now some of you had a unit or a section of the unit on sets and Venn diagrams. So I'm going to quickly go over some of the terms and some of the problems that you might attack using these. A Venn diagram is basically a big rectangle called a universal set, and sometimes it has a big U in the corner, sometimes it doesn't, but it usually has some circles. And in this case, I've got 2 and they're overlapping. They don't have to be overlapping. There doesn't have to be 2 circles, but a Venn diagram is basically the rectangle and something inside of it. This Venn diagram shows the intersection of sets M and sets N, represented by the 2 circles. The intersection, which is represented by this upside down U, is 4, 7. 4, 7 are the whole set that represent the intersection of sets M and set N. The union, which is written with the right side up U in between the 2 set names, would be 3, 4, 6, 7, and 9, because the union takes all the members of both sets and puts them together, 3, 4, 6, 7, and 9. The universal set in this case adds on the numbers that are outside the circles, 2, 5, and 8. So the whole set would be 2, 3, 4, 5, 6, 7, 8, 9. That's the universal set in this case. Now, when we talk about sets, we talk about some symbols and names of other things that go with it, like subsets. Subsets, represented by this little kind of cursive E, are completely included in another set. Empty set can be written, or null set or no set, is represented by an empty set of braces or possibly a 0 with a line through it. And remember that that's a subset of every other set. So if you're asked to find the number of subsets that can be created out of a certain set of numbers, make sure and add one on for the empty set. We talked about the complement of a set. The complement is whatever is not in that set. So for instance, this one, 2, 4, and 6, they have a line above them. So that line is read as complement. So if you were asked to find the complement of set 2, 4, 6, you would choose all of the other numbers that are in the universal set. So for instance, in the set above, if there was the complement of sets 2, 4, 6, you would choose 3, 5, 7, 8, 9. Now, if 2 is a subset of set A, this is completely not to do with this illustration, 2 is not a subset of set B, then 2 is not in A intersects B, because anything in the intersection or the overlapping space has to be in both sets. If it's not in B, but it is in A, then it is not in the intersection of the two sets. Here's a problem that you can use a Venn diagram to figure out. There are 250 commuters waiting for a bus in the rain. If 180 are wearing a raincoat and 60 are wearing a raincoat and carrying an umbrella, how many commuters are only carrying an umbrella? To figure this out, the first thing I have to do is split up my raincoat wearers. I know there's 180 total that are wearing raincoats, but 60 of them are in this intersecting area because they're also carrying an umbrella. So 120 are left over that are wearing raincoats but not carrying an umbrella. I know that there are 250 people in all. So if I subtract 180 from 250, I end up with 70 people who are just carrying an umbrella. Now, if I were asked to figure out how many people are carrying an umbrella altogether, that would be 60 plus 70, or 130. A universal set contains only sets A and B in this illustration. You can see that they don't overlap, so there's not going to be anything in the intersection. The question says, if A intersection B is the empty set, such as what's illustrated here, and A is not the empty set and B is not the empty set, then these four things are true. A and B are disjoint. Disjoint means they don't touch, they don't overlap. A equals the complement of B, because whatever is not in B has to be in A, because there's nothing outside of it. A is not a subset of B, so it's not entirely inside it, and the intersection of A and B is the empty set. Okay, that's all I wanted to go over for this review. If you still have some questions about what was in this unit that you're having a hard time with, that you want to ask about before you take the unit test, just send me a message, or when you call me about this video, just let me know and I will be sure to answer that question for you. Thanks very much for participating and good luck on the exam.